Hey, welcome back to my channel. Today, I decided to talk about how playing computer games can affect our brains. First, let's see how the brain works. The brain is made up of networks of neurons. It's estimated that the adult human brain contains approximately 86 to 100 billion neurons. There are synaptic connections between neurons. The brain has a vast number of connections between neurons. In fact, some estimates suggest that the brain contains up to 100 trillion synaptic connections. This number can vary depending on the method used to estimate the number of synapses, as well as the specific region of the brain being studied. Nonetheless, it is clear that the brain has an incredibly complex network of connections that enable it to process information and carry out a wide range of functions. The process of decision-making in the brain involves the integration and processing of information from many different neural circuits and pathways, including synaptic connections between neurons. The brain has the ability to store and retrieve information, which is commonly referred to as memory. The communication between neurons in the brain involves the transmission of electrical signals, which are often referred to as neural impulses or action potentials. But two neurones are not connected directly. There is a small gap we call as a synapse. Electrical current passes through neurons, but across the synapses, signals are transmitted chemically. That means same as current chemicals also incorporated to do that. We call it as electrochemical communication. If two neurons were directly connected without gaps, it would likely affect the ability of the brain to learn and process new information. This is because the flexibility and adaptability of the brain rely on the ability of neurons to form and modify connections with each other. In a brain where neurons were directly connected without gaps, the connections between neurons would be fixed and inflexible. This would make it difficult for the brain to adapt and change in response to new experiences or learning. Fortunately, in the brain, most of the connections between neurons are chemical synapses, which provide the flexibility and adaptability needed for learning and information processing. So, while electrical synapses do exist in the brain, they are relatively rare and are not believed to play a major role in learning and memory. The brain is capable of both strengthening and weakening connections between neurons. Simply, the brain has the ability to create new neural connections or circuits, a process known as neuroplasticity. When you repeatedly perform a certain task or engage in a specific activity, the neural pathways associated with that task or activity become stronger, while the pathways associated with less frequently used activities weaken over time. This is known as the use it or lose it principle of neuroplasticity. If you play chess frequently, the neural circuits in your brain responsible for chess playing will become stronger and more efficient. This is because the brain has a remarkable ability to change and adapt in response to new experiences and learning, known as neuroplasticity. As you continue to play chess, your brain will create and strengthen new neural connections between the relevant neurons, making it easier and quicker for you to analyze the game and make strategic moves. This also means that the neural circuits that are not used as frequently will weaken over time as the brain reallocates its resources to the circuits that are being used more often. When you think creatively and use your imagination, your brain will activate a network of neural circuits involved in creativity and imagination. With repeated use, these circuits will become stronger and more efficient, making it easier for you to come up with new and innovative ideas. This process of strengthening neural circuits through repeated use is an example of neuroplasticity, which is the brain's ability to change and adapt in response to new experiences and learning. In those cases, the chemical concentrations of the synapses increase when you use them more frequently and decrease when you use them less. There are two places in the brain where the processes of feeling and logic occur. The emotional processing unit is called the amygdala. The other part responsible for logical processes is the prefrontal cortex. After our brain generates a feeling as Homo sapiens, we can decide whether that feeling is valid or invalid. As far as we know, humans are the only animals that have the ability to reflect on and question their own feelings and emotions and to determine whether they are valid or not. While other animals may experience emotions and have some level of self-awareness, they do not have the same level of conscious introspection and decision-making capabilities as humans. Okay, that's enough for today. Remember these things and see you in the next part to video where we will see how computer games impact the brain. Thank you for watching. Don't forget to subscribe my channel.